Right, so simplifying rational expressions is the title. What is a rational expression? What's a rational number? How do you know something's rational? Just by glancing at it. What can be written as? Any rational number can be written as a what? A fraction. Okay, so that's all a rational number is. A number that can be written as a fraction. So 4 is a rational number because 4 over 1 is a fraction. 8 over 2 can turn into 4, right? Any number that can be written as a fraction. When we're dealing with fractions, the important thing to keep in mind is what can the denominator not be? What can the denominator not be? 0. Okay, so that's it. And these are expressions, meaning they do not have equal signs. All we're going to do is simplify them. We're not going to get x equals 5. Here, x equals 7. We're just going to factor and reduce. That's it. It's not an equation. It's an expression. Okay? So before we start, though, we're going to do a little bit of review on reminding you how to factor. And some of these are easier than others. So I'm going to put 3 up and see what you remember. First one is x squared minus 4. And then x squared minus 11x plus 24. And the last one is x cubed plus 27. So quickly, see what you remember about factoring. We've had a test over this. So hopefully you remember a little bit. Factor them as quickly as you can. Alright, for A, it's the difference of perfect squares, right? So you should have just gotten x plus 2x minus 2. Agreed? That was kind of straightforward, right? Good. And then for B, B is a trinomial. Those are the easy ones because they're missing the leading coefficient, right? Those are the ones where you can just glance at it and put your A in. Go ahead and build your parentheses. Since this is x squared, you put an x and an x. And then now I just need to fill in the other two numbers. Numbers that multiply to give me 24 and add to give me 11 or 8 and 3. I want a negative and a positive, so they both are negative. Now the hardest one to remember might be C. Those are perfect what? Cubes. Okay, and that's the ones on the test that some of you struggle with. Cubes, when you factor them, get a binomial and a what? Trinomial. Okay, well if you remember that, you're one step closer to knowing it. So build your binomial and your trinomial. And our trinomial came from, remember, SOFAs? That helped us kind of our little cheat way to remember it. So this is SOFAs, S-O-F-A-S. And before we could do anything, we had to take, since they're perfect cubes, we take the cube root, not the square root. So this becomes an x and a 3. So the first one is just exactly that, x plus 3. Now see if you can fill in the next part. Square, opposite, factors, add, sum, square. You get x squared minus, factors come from the 3 and the x, add 9. Is that what you got? Okay. So we're pretty good. Now we have 2 left. Remember, these are just reviewing on factoring. So here's your last 2. Xy squared minus 7y squared minus 4x plus 28. And E is 3x squared plus 14x minus 5. So we have the factor by grouping, and then we have a factor with the leading coefficient. Do you remember how to factor by grouping? What did we do? We took one set, right, and then the other set. these. Right? Okay, you're remembering a little bit more now, right? What can I take out of here? I can take a y squared out, leaving me with an x minus 7. In here, I'm leaving with a negative 4, so remember we took the negative out, so keep it the same. So negative 4, leaving me with an x minus 7. Now you're going to notice I have y squared times this, x minus 7, and negative 4 times x minus 7. So both of those things multiplied by an x minus 7. So the way we write it is just y squared minus 4 times x minus 7, because it's y squared distributed to both and 4 distributed to both. But there's still one tiny little step left in order for us to earn full credit. What we need to do, what do we have to recognize here? Yeah, so what is it? Good, Nick. This is a perfect square. So this is y minus 2 times y plus 2, and then x minus 7. All right, on E, put a star, because about 80% of you struggle still with factoring numbers like E. Okay, when you factor a trinomial with a leading coefficient, we use the rainbow, remember?
Yeah.
Okay, so we want numbers that are going to multiply to give me negative 15 and still add to give me that middle term of 14. Okay, the only way to get 15 is 1 and 15 and 3 and 5. But to get 14, we're going to use 1 and 15, right? So 1 and 15, and the 1 is negative. And then what kids tend to do is they tend to write x minus 1 and x plus 15. But if you check it, you would be wrong. What did they forget? What do you have to do to it?
Divide by 3.
Yeah, you multiplied the 3x in, you've got to bring the 3x back divided by both. Split it into 2, right? Now you can have your answers. This one is 3x minus 1. And this one reduces to x plus 5. And now let's check. 3x and x is 3x squared, and 1 and 5 is negative 5. It works. If you'd left it the other way, it would have been wrong when you checked it. That's how you'd know. Just remember, when you have a leading coefficient, use the rainbow method and then divide it back out. If you forget, that's why we took notes right there. Come back and check it. Any questions about how I got that answer? All right, then let's move on to actually factoring. So let's simplify. Okay, keep in mind that the denominator cannot equal 0. That's important. Here's our first example. If I tell you 10x squared minus 4x over 2x cubed. There's two ways of looking at this. You can either A, find something that fits into all of them, or to keep it simple, you can just factor the top, factor the bottom, and reduce what you can. Okay, and that will always work. So what can you factor out of the top here? What? A 2 and an x, okay? You can actually take it out of everything, but let's just try it this way. And then you end up with 5x and a 2. You can't take anything out of the bottom because it's, there's no addition. Right. Now then, before we actually cancel, so step 1 is to factor everything. We did. Before you can cancel, you're going to look for your zeros. So you factor and look for your zeros. In other words, what I mean by that is, when is my denominator going to equal 0? Think about this for a second. If I put a 1 there, 1 cubed is 1 times 2 is 2. So, okay, I can put a 2 there. What can I not put there? What's going to give me 0? 0. So what can x not be? 0. Right? So let's write our restriction, and that's required. That's part of your answer. X can't be 0. Now then, let's cancel. Okay? So the 2's are going to cancel. 1x is going to cancel, leaving me with 2 in the bottom. Right? So then your final answer is the 5x minus 2 on top and an x squared on bottom. Can I cancel those x's one more time? No, it has to fit into everything to cancel. There you go. Number 2. Okay, let's do 5y cubed over 10y to the 5th minus 5y to the 4th. Again, some of you may notice 5 goes out of everything, but sometimes it's hard to find the zeros if you don't factor then cancel. Okay, so let's factor, find zeros, then cancel. Can I factor anything out of the top? No, it's just going to leave it the same. What comes out of here? A 5, and how many y's can I plug? 4. Leaving me with 2y, and this is exactly the same. 2y minus 1. Now let's look at this and decide what would make this equal 0. Okay, you're going to have to look and see.
1.
You're going to have to look and see, okay? And you have to think about this, that these are kind of their own separate units. In other words, if this is 0, 0 times this would give me 0. Or if this value is 0, no matter what is over here, 0 times anything is 0. So we have 2 different answers potentially, right? So if you look at just this part, what value for y is going to make that part 0? 0, okay? So y equals 0. Y cannot equal 0, sorry. This is harder. Some of you can do this in your head. Tell me what you think it is in your head. What can y not be here? If you can't do it in your head, I'll teach you how, okay? So in my head, I'm thinking to myself. This is what I'm thinking. Zero think box for a second. I know 2y minus 1 cannot be 0. Right? That's what I'm saying to myself in my head. And if you want to write it out every time, you can. So what I'm going to do, though, is in my head, I'm going to be like, okay, I know I'm going to have to bring the 1 over. So now I know 2y can't be 1. Right? And then to solve for y, we're going to divide everything by 2. Correct? So then that means y cannot be what? 1/2. But if you want to just look at it in your head, you can say, okay, move the 1 over, so it's 1. And now divide by 2, so 1/2. Either way, you can set it equal and try, or you can do the math in your head. So those are the 2 things we can't be. Because if I'm 0 or 1/2, my denominator is 0. Now let's cancel and find the answer. 5's go away, y cubed goes with this. And then now on the top, all I'm left with is 1 in the numerator. In the denominator, I'm left with y times 2y minus 1. Do not distribute that y back out. You don't want to risk making a mistake when you multiply out and losing a point or 2. And not to mention, you can glance at that and know, okay, it's factored, nothing else cancels, I'm good to go. Don't do more math, do more work just because. You run the risk of making a mistake. Number 3. X squared plus 2x minus 3 over x squared plus 6x plus 9. Both of those are trinomials. You want to factor first and then find your zeros and then cancel. These are easy to factor because they don't have a what? There's no leaving, right? So automatically know that my answer is just 2 sets of binomials. You want numbers to add to give you 2, multiply to give you 3. So fill in your x's. The only way to get 3 is 3 and 1. Right? And then here's add and multiply. So you're going to do 3 and 3. Before you cancel, go ahead and list what zeros are. What can x not be here, guys? It's the same thing, isn't it? These are both the same. So what can x not be? Not 0. X can't be negative 3. Negative 3 makes the denominator 0. X can't be negative 3. Because negative 3 plus 3 is 0. X plus 3 is cancelled. That's a unit. So some kids are asking me, how am I allowed to cancel that? is this unit multiplied by this unit. The whole unit cancels. It's kind of like if I told you 3x over 5x, right? The x unit cancels the x unit, give me 3/5. Right? It's the same thing. This cancels with that. So the answer is just x minus 1 over x plus 3. Number 4, x cubed minus 2x squared minus 8x divided by 2x squared minus 8. What can I take out of the numerator? What do you see? Perfect. What can I take out? The x. Cool. So take the x out. And then what can you take out of the denominator? A, 2. So do them both real quick. Okay, but they can both be factored again, can't they? The top's a trinomial and the bottom is perfect squares. So on the top, I'm going to refactor it. Okay, numbers add to give me -2, multiply to give me 8. They're going to be 4 and 2. X minus 4, x plus 2. And then the bottom, what do you notice about the bottom? It's the difference of perfect what? Squares. Good. So x plus 2, x minus 2. Before I cancel anything, you have to pick your zeros. Guys, don't pick your zeros after you cancel because you might forget one, right? When to factor, then pick your zeros. So right before you cancel, pick your zeros. So what's going to make the denominator 0? 2 is going to work here. What's going to be here? -2. So x is not allowed to be 2 or -2. And then now you can cancel. You end up with x times x minus 4. 2 times x minus 2. Questions on that part?
And the thing on the side, that's part of the answer.
Yes, the restrictions are part of the answer. Good question. Okay, for 5, let's do 9x squared plus 13x plus 4 over x plus 1 times 8x minus 7.
Next.
Okay, I'm going to give you a minute because I want you to practice factoring with these leading coefficients because maybe you still struggle with it. So try this one. Try to factor it. 9x squared plus 13x plus 4. Alright, so you're looking for numbers that multiply to give you 36, remember? And add to give you 13. The two numbers are 9 and 4. But don't forget to put them over 9x, both of them. So that, and then this cancels. So you're left with x plus 1 and 9x plus 4 in the numerator. And then x plus 1 and 8x minus 7 in the denominator. So those cancel, and you're here. Okay, and I forgot, I'm sorry, to, once I factored it, to look for my restrictions before you cancel. So before I actually cross these out, what are going to be my two answers x cannot be? So this one is -1.
And 1?
This is a little harder. What's this one going to be?
I think it would be
Move the 7 over and divide by 8. Right, 7/8. So those are the two things x can't be, because if it's -1 or it's 7/8, then the denominator is 0, right? You can't divide by 0. And then so your final answer then is 9x plus 4 over 8x minus 7. Number 6. How'd you get the 8? right here? The same x or this one?
The 8x, no, the 8x up there. Because it was 4 divided by 9x.
Okay, so in the top, this became x plus 1,
Oh, okay, I was
and this
in the
became 9x plus 4. Do you see it?
Yeah, no.
These came from the denominator.
Yeah, I looked at the wrong one.
Now, for number 6, what do you notice about these? Some of you can just glance at this and know the answer. But what do you see that's weird about it? Any answer. There's lots of different things that could tell me that's different. What?
They use the same numbers.
Same numbers. Excellent. What about the same numbers, though?
The signs opposite.
The signs are opposite?
Signs. The opposite.
Right. So what do you think? If you had to guess, what do you think the answer would be? They both have an x, they both have a 2, and the sign's opposite. You want to just reach out there and just grab at what you think it might be?
1.
You're very close.
-1.
Right. -1. Okay, let me show you why. Okay, if I replace this, I've got an x and a -2. Let's go ahead and leave that alone. And let's change the order of these to -x plus 2. Okay, right? So now they look even closer to the same. Now do you see where the -1 is coming from? Okay, the way this works, when you glance at them, if they're both opposite. So here's a positive x and a negative x, and -2 and +2. They're both exactly opposite, right? So on either one, I'm just going to do it with the bottom. It doesn't matter, okay? But I'm going to factor out a -1 here. When I factor out a -1, I take the opposite, and I take the opposite. You'll see that? Now, are they exactly the same? Yeah. Do you see how they're the same now? It only works when they're both opposite. In other words, positive x, negative x. -2, +2. In other words, both signs are the exact opposite. Okay, you can take a -1 out of one of them, and then they'll match perfectly. And now that these cancel, and it's just 1 over -1, which is -1. What can x not be? What's my restriction? You want to do it before you cancel, so you can do it right here. What I put right here would make it 0?
2.
2. X can't be 2. Number 7. Let's do r squared minus rs times s squared minus r squared, then -1. Does the -1 apply to both sets of parentheses or one set of parentheses?
1.
1. So which one is going to get kicked down? What does the -1 mean? Yeah, it meant in a situation like this, so you have x squared and x cubed, it just meant that you had an x left in the denominator, right? We write it as x to the -1 to let us know that the leftover x is in the bottom. So it means that s squared minus r squared belongs actually in the denominator, okay? And if you didn't already know that, you can write yourself a note. And if you already knew it, you don't need to know. Now factor. You can take an r out of the top, giving you r minus s. And in the bottom, it's a difference of perfect squares. And I'm going to give you a second to try to see what cancels. It's going to be a little bit similar to the number 6. Right, what do you notice? And guys, here's the issue with this. We're going to get the same answer, but you might notice it a little different spot. But this is a positive r and a negative s, correct? And this is a negative r and a positive s. I notice it on these two. Did y'all see that? They're exact opposite. So on either one of them, what do I need to take out so that they will match? -1, right? It doesn't matter where you do that. Okay, I'm going to do it at the top. It doesn't make any difference. So I'm going to make, instead of r, let's say I factored out a -r. So now I will have a -r plus s. In the denominator, I've got s plus r and s minus r. So here are -r, positive s, -r, positive s. These cancel. Right? So if you have your negative down here in the bottom or the top, it doesn't matter. 4 divided by -1 or -4 divided by 1, it's the same. So then my answer is this. If you wrote this, negative s minus r, either one is fine. Okay, it doesn't matter. Alright, now this part is a little bit tricky. We've been labeling all of our restrictions. So let's kind of put our thinking hat on for a second and talk about this. Right, you want to do it before you cancel anything. And let's think about what my restrictions would be here. I realize that s and r are both variables and there's no numbers. So let's just pretend they're a number. Okay? For example here, s minus r. When would an s minus r be equal to 0? What if they were both 3? What's 3 minus 3? 0. What if they were both 100? 100 minus 100 equals what? 0. What if they were 5? 5 minus 5 is 0. So what can they not be? R and S cannot be what? Good. They just can't be the same. Okay? It's just a tiny different. You'll notice there's no numbers in this problem, and that's why it looks a little different. So R cannot equal S. Okay, how about this one? Okay, you're adding two numbers. So I'm going to add two numbers. If they were the same, like 3 plus 3, that'd be 6. I'm safe. 5 plus 5, 10. I'm safe. What can they not be in this situation? Good. Opposite, right? 3 plus negative 3. 5 plus negative 5. Do you see what I mean? So in this situation, R can't equal the opposite of S. Or S can't equal the opposite of R. Either way, you can write it either way. That was a little different. You get used to it because they're pretty simple. But let's go to number 8. A minus x squared divided by x squared minus a squared. You're not going to want to FOIL the numerator. You're just going to want to write it twice, okay? So that in hopes that something cancels. So you're going to say, all right, a minus x and another a minus x. And then how do you factor the denominator? Try it. Do you get x plus a, x minus a? Okay. And then the same problem that we've been having. Negative x, positive a, positive x, negative a. These two right here are exactly opposite of each other, aren't they? So in order for them to cancel, what do I have to do? I have to take out a negative, right? So then if you do that, okay, then take a negative out of, let's say I'm going to take it out the top. So in -1, I'm going to change this to negative a plus x. Do I take it out of both or just one? Just one. Okay, because if I take it out of both, I turn it back into positive. So just take it out of one. Okay, negative a positive x. So this cancels with this. So you're just left with -1 times a minus x. And if your negative is in the top or bottom, it doesn't matter. What about my restrictions? You want to do them before you cancel, so you can do it right here if you want. It is the same as before. X minus a, right? 3 minus 3, they can't equal to each other. So you don't want x to equal a. And here they're exactly the same and you're adding. right? So they can't be opposite of each other. We have 10, so we're going to go to 9 and then 10. P squared plus 4p minus 5 divided by p minus, not divided by, sorry, times p minus 1 to the negative 2 power. What does the negative 2 say for us to do? What does negative mean? It goes in the denominator, and how many do we need? That's what's tricky. The last one just sent 1 down. How many are you going to need here? 2. Okay. So technically the problem reads p squared plus 4p minus 5 over p minus 1 squared. If you rewrite it though, you're going to factor this to be p minus 1 times p plus 5, and you want 2 of these. P can't equal 1, because 1 minus 1 is 0. These cancel. We've got a 5 and a 1. Yes.
I'll move the denominator to like the top part. Why is it both minus 1? Like,
Because it's p minus 1 squared, so it wants 2 of them. I know. It's not the factoring of difference in perfect squares. Very easy mistake. Okay, last one, number 10. This one, a cubed minus a squared b plus ab squared minus b cubed divided by a to the 4th minus b to the 4th. It's really not too hard. You just are going to have to be sure you keep in mind how to factor by grouping. Do I remember how to factor by grouping? We're going to put these together and these together. So if we take the top, you end up with, what can I take out of here? So a squared times a minus b, and on these I can pick out b squared. In the denominator, this becomes a squared minus b squared and a squared plus b squared. But this can be factored again. So you have a plus b times a minus b, and then a squared plus b squared. One over a plus b. Okay, the restrictions are a little harder on this one. I'll let you try it. You're going to look for your restrictions right here. Right here before you cancel. Look in there. So in here, a minus b, so it'd be like 3 minus 3 is 0, right? So you don't want them to be the same. And on here, you don't want them to be opposite, 3 plus negative 3, right? Which would be the same as this one. This one wouldn't qualify if it said equal to 0, then it should be 0. So you're at a equals b anyways. Very good. Okay, you're finished, we're going to practice. I'm going to walk around and check to be sure that you're doing okay.